Hi, in this video I will explain location added routing. This routing uses the location of node to find out the route for the destination. So the used location actually fetched from global positioning system GPS using GPS. So the coordinate of every node, it is assumed that every node knows its own current location. So let's start. So this is a brief of LAR. LAR is a mobile ad hoc routing protocol. Location ad hoc routing. This routing, whenever a node wants to send information to another node, or if there is a error in a saved route, in that case, a node will initiate route discovery process through which they will find out the destination node. And here GPS is used through which every node can know okay what its current physical location. So this routing actually having two phase. One is route discovery through which route request packets are sent to the or broadcasted to the destination. And once destination receive a route request message, destination will reply by sending a route uh, reply packet. And if there is any link broken during transmission, so this error will be reported to the sender by sending a route error packet. So these phases are actually similar to DSR, dynamic source routing, in which whenever a node wants to send a data to another node, a sender initiate a route discovery, then the destination start route reply, and if there is any error, route error will be started. So in LAR uses a variation of flooding. Flooding is a mechanism through which a message will be broadcasted to every node in a network. But here, location added routing don't use flooding as it is. They are using a variation of it. And what is the variation? For example, say S wants to send something to D. So S will broadcast this message to its neighbor, and S is having two neighbors A and B. Now A is having neighbor S and C, B also having neighbor S and C. So these two again broadcast these messages to its neighbors. So here if you can see, this node is receiving a request packet which are already sent by this node. So if a node sent a route request message earlier, in that case that node will not broadcast this packet again. And how this thing these node would know this thing, that whether the received request packets are already being sent by the same node or not. So a sequence number is used with every route request, so it can stop flooding at some point of time, otherwise this flooding will keep on going. So this is the variation of flooding which is going to be used in location added routing. If a route request message has been sent from a particular node, in future if that node is receiving same copy of that request, in that case that node will not broadcast it again. Sequence number is the mechanism through which this will be achieved. Now LAR divide network into two zones. One is known as expected zone and another is request zone. Expected zone can be considered as an area in which the destination will be available. So this is the area with, where destination is moving. So expected zone is a area in which this is considered that destination D will be available in expected zone. And second zone is the request zone. What is the meaning of this one? When a route request message is sent by sender to destination, so there are a number of intermediate nodes. Those intermediate nodes receive those requests and broadcast it again. So request zone specify a area in which if a intermediate node receiving any route request, that intermediate node will forward that packet. But in case if a node is outside that request zone, and if that node is receiving a route request message or request, that node will not forward it. So request zone will specify area where which will specify that any node in this area only broadcast request packets. So we will see how these zone actually been formed. So what is expected zone? So here we are considering source as this is a sender and this is the destination, and we want to find out expected zone area where this node D will be available. So let's assume that D last location of D is known to S, and which is say XD or YD, and we are saying at time T0 S no knew the position of D, and the current time is T1. So we are S is having information which is not uh, updated. At T0 S knows that this was the location of D, and D is a mobile node. So we consider if D is moving with V average speed. So after time T0, the total time spent is T1 minus T0. Speed is V. So we can consider this node D will move V multiply T1 minus T0 distance. Distance can be calculated by multiplying speed with time. So this this distance can be covered in any direction. So here this is the formula given. This is the distance which is covered by destination D in the time span T1 minus T0. So the shape of expected zone is considered a circle. So at time T1, node D can be found in this area. Why we are using a circle? Because D can move in any direction. Now, if the sender, sorry, if the sender knows the extra information, like this node is only moving in the north direction. So we will take that scenario later. So this is the expected area. Now if the extra information is known to sender, so this is expected zone can be reduced. So let's take an example. We are taking that destination node is moving only in north direction. So in that case no need to consider the full circle. So we can say the expected zone will be only half circle, because it's already given that node is not moving in the south direction. So the radius of this circle will be V multiply T1 minus T0. So this is the expected zone area where the destination node will be available. Now second second one is the request zone. Uh, let's take this example first, then it will be clear to you. Say this is a mobile ad hoc network, and we are saying these nodes are in request zone, and this node wants to find out a route for this node. So it will initiate a route discovery. It means it will send route request packet to all of its neighbors. So if you can see, these two neighbors lies in this area, and this neighbor is outside the area. So if a node is outside, that node will not broadcast route request packets. So here if you can see, only these two nodes are again retransmitting, again broadcasting the route request, but this node and this node, these two nodes are not broadcasting any packet. So request zone will specify the area in which if an intermediate node lie in that area, in that case they will broadcast the route request packet, otherwise they will discard it. So this is the how it works. Now how request zone is formed, what are the criteria, who is going to specify that this is the request zone. So location added routing actually have two different schemes to find out whether a node in the having membership for a request zone or not. So first scheme, this is the first scheme. What is that? In this scheme, shape of request zone is considered rectangle, and the second constraint is this rectangle will include expected zone and the current location of node S. We are considering node as the node who is initiating route request query. Let's take an example to clear this concept. Uh, this is the node S, and we are considering these are the coordinate of node S. For simplicity, we are considering coordinate in two plane xy. So these are the coordinate of node S, and say xd and yd. These are the coordinate of node D. So our first constraint saying that shape of request zone is rectangle now, and second one is saying this request zone should include coordinate of S and expected zone of D. So this X, D and Y, D, we are seeing this is the last known location of T at time T0, and at time T1 S is initiating route request query. So in order we want to find out the expected zone of D, so for that we are considering V is the average speed of node D. So we will say this is the expected zone of D. Now if we will draw a rectangle which can include node S and this circle, that will be the request zone. So this is the expected zone and this will be the request zone, including node S and expected zone of node D. So when S will send this route request packet to its neighbors, so how it going to specify that this is the request zone? So what it will do, it will include four coordinates of this rectangle. This coordinate can, we can see, if this is the yd, then if you add r, you will get the coordinate of this one, and here xs will be same, so xs plus yd plus r. So similar way these coordinate can be calculated. So when this node s will send a route request packet, these four coordinate will be included in those packet. Now now take the another example. So in this example we are showing node as lies in the expected zone of node P. So in that case uh, node S is already in the expected zone. So if we will draw a rectangle which can include node S and the expected zone of node D, so this will be the rectangle. So now we will see the route discovery process of scheme 1. So this S will broadcast its route request packet to all of its neighbors, and that request will be having four coordinate of request zone. So these three nodes will receive a copy of route request packet. Now every node is having information about their own location, about their own coordinate. So this node will check whether this coordinate of this node is lie in the request zone or not. In other words, we can say if this node lie in this rectangle or not. So here we can see this node is outside the rectangle. It means this node will not broadcast this message further. But here these two nodes are in request zone, so they can forward. And here we are showing only operation of this node. So this node is also eligible. So this node also will send route request packet to its neighbors. And when the destination D receive this route request packet, it will insert its current location and the time in the route reply packet and send it to the node S. Uh, okay, what is the meaning of these blue lines? They are representing when this node is sending its route request packet broadcasting, so that one copy also received by S. Same with this one, but this one will not send it again because those requests actually already has been sent from node S. Now this is scheme 2. Uh, scheme 2, when a node send a route request packet, that route request packet now don't include 4 coordinates of rectangle or request zone. Now they include only two information. One information is the coordinates of destination D. So we are considering that node as no location of D at time t0. So coordinates of D will be included in the route request packet. And we are considering node S will initiate a route request at time t1. And second component which is going to be included in route request packet is the distance between destination node and the sender. So two component, one is the distance and one is the coordinate of destination. So now we will see how this request zone will work in this scenario. So sender will prepare a route request packet, and here we are showing only two attributes. Actually there are many attributes like sequence number, other things, but for simplicity we are considering uh, coordinate of D and distance between S and D will be included in the route request packet, and those packet will be broadcasted. So broadcasted, S will send one copy to each of its neighbors. Now when this node receive one copy, what this node will do in order to find out whether this node is eligible to forward this packet to its neighbor or not, this neighbor receive a packet, that packet having coordinates of t, so and this node is having uh, location of its own, so this node will calculate distance between destination and itself. So if this distance is less than the distance between S and D, which is included in the request packet, in that case it will broadcast packet, otherwise it will discard. So here we can see this distance is actually greater than this distance, so this node will not broadcast any request packet. So let's take this example. When this node will receive the request from S, this node also calculate the distance between D and its own, and this distance is less, so this node will broadcast route request message, route request packet to its neighbor, and this will happen. So one copy will be sent to destination D, and D would know someone is trying to search the route to reach me, and D will send a reply to sender. Now so in our example we just consider a distance, but actually this distance calculation is include two parameters, alpha and beta, where alpha represent probability of finding the route in first attempt and beta represent cost of finding out. So initially we consider alpha equal to 1 and beta equal to 0, which is equal to our last assumption, whatever the last scenario we have discussed. But these can be used as a trade-off between these two. These value can be changed. This is used to consider a trade-off between these two. So this is location added routing. Thank you.